So here we're asked, what does x equal? We're not given much information. So here the solution outlines trig ratios and kind of angles for triangles. So what we can do here is kind of just go over generally the fundamental trig ratios to know and the special triangle. So we know that we have the mnemonic so ga toa. This just means that so is sine theta equals opposite over hypotenuse. So that's the first one. And then we have cos theta is adjacent over hypotenuse, and then tan theta is opposite over adjacent. So I'll underline where this, so here we have the S is sine, OH is opposite over hypotenuse, C is cos, AH is adjacent over hypotenuse, T is tan, and we have OA for adjacent over hypotenuse. So this is for a right angle triangle. So if we had a right angle triangle like so, and we were trying to solve for theta, this would be the opposite side, this would be the adjacent side, and this would be hypotenuse. And the reciprocals of sine, cos, and tan would give us the following. So cosecant theta is actually 1 over sine theta, and this just equals hypotenuse over opposite. And then secant theta equals 1 over cos theta, and this equals hypotenuse over adjacent. And finally, cotangent theta is 1 over tan theta, which equals adjacent over opposite. So these are kind of the fundamental ones to know for trig ratios when we're solving for theta. Let me just check something over here. All right. Just give me a second. Okay, so secondly, what we also should know, or an important kind of fact to know, are the special triangles. So there's two. We have the first one, which has a right angle over here, and then we have a second one that's a little bit longer and has a right angle over here. So this is useful whenever we're solving any kind of problem that has triangles. So for this triangle, we have 1 square root 2, and then this angle is 45 degrees, and then this angle is 45 degrees. And the second special triangle is 1, 2, square root 3, and this angle is 30 degrees, this angle is 60 degrees. So we can see how SOHCAHTOA might come in handy here. So let's say we're looking at this angle. So if you wanted to say what is sine 45 degrees, we know it's opposite over hypotenuse. So opposite, which is 1, so this is 1, over square root 2, square root 2. So that's the easy way to evaluate that. You can also look at, let's say, another example would be tan 45 will be opposite over adjacent, so opposite over adjacent, which is just 1 over 1, which just equals 1. You can also look at the second triangle. You can do the same for the rest of the trig identities. So cos, cotan, secant, and follow the same rules. So here, if we said, what is sine, or sorry, let's use cos. Let's say cos 30 degrees. We know cos is CAH, so ca. Adjacent over hypotenuse, so adjacent over hypotenuse, and we know it's square root 3 over 2. And let's say we want to do secant 30 degrees. So secant is just 1 over cos, so it would just be 2 over square root 3. And similarly for sine and the rest of the trig ratios. So here the outline kind of same idea, but they use kind of different variables to represent adjacent and opposite. And they kind of create a table for all the sides and all the ratios for the angles. So here, okay, so they go through a process to evaluate for the angles. And they go through some examples. So, all clear question, correct explanation. They don't really show special triangles, so we'll take that out. Okay, let's go to the next question.